Alright everyone, statistics becomes a very important component. Statistics becomes a very important component when you are looking at any kind of analysis, any kind of future projection, forecast or anything that is needed. When you are looking at statistics, basically there are two kinds, there are two ways in which you can talk about statistics. One is descriptive, one is inferential. When you're looking at descriptive statistics, you can look at charts and graphs and all of that, and you can see how the data has been trending. So basically what we are trying to do in statistics, when we study statistics for finance or statistics in general, not a problem. When you're studying stats, that is because you want to study the past data, and on the basis of past data, you want to forecast something in the future. You want to study that, okay, these are the last 10 years data, 5 years data, 100 data points, 200 past data points. So how is it going to behave in the future based on the past is what we are trying to do when we are looking at statistics. Right? Now the terms in statistics are very easy, and we'll be proving the formula of standard deviation and variance and all, so you'll not have to worry. So when you're looking at statistics, one, let me take an example. Let's say I'll talk about SBI, that is the State Bank of India. That's one of the largest public sector banks in India, and let's say we're talking about interest rates. So now the SBI, the stock price of that bank, SBI, should depend on interest rates. It's a very important factor. Now suppose I want to analyze the price of SBI. The average, mean, median, mode, variance, standard deviation, skewness, kurtosis. So we'll discuss each of those terms. So when you're looking at analyzing one stream of data, you're looking at mean, median, mode, range, mean absolute deviation, variance and standard deviation, skewness, kurtosis, I know there's a lot of terms over here. We'll be understanding the meaning of each and every one of these, and then we'll get into the details of it. So when you're looking at a data, let's say I want to analyze the price of SBI, State Bank of India. I want to analyze the prices, the stock prices, the share prices of State Bank of India stock, SBI. It's trading at somewhere around 300 plus at the moment, 310, 11 or something last day. When you're analyzing the price of SBI, these are the attributes that I will check. When you are looking at the relationship, when you want to understand the relationship between two variables, how is the movement of SBI and interest rate related to each other? In that case, you will be looking at this one. Sample and population is another term, wherein, I'll give you a very simple example. We have these elderly generation people. I use this example very frequently. We've got these elderly people who say that, that their two kids, if they're fooling around, or they are doing some mischief or something. So these guys like, this is what your school teaches you, or this school's kids are like that. They'll immediately comment on this manner, कि यही सिखाता है school में, यही ऐसे school में यही सीख के आते हैं, and all these kind of comments. What is that guy doing? Based on two children's behavior, based on two kids' behavior, he's extrapolating to the hundreds of kids who are studying in the whole school. He's looking at the behavior of two kids, and it doesn't take him a second to extrapolate that kid's behavior to the whole school. That because two kids are behaving in this manner, then the whole school is going to be like this. That's how these guys comment. That is sample and population. What we are trying to do in statistics, you want to study the past data in order to make a forecast about the future. You want to study the last 10 years data, and on the basis of that analysis, on the basis of the analysis of that 10 years data, worth of data, you want to make analysis of the next year or two years or so. So forecasting becomes very important. Forecasting statistics becomes very important when you're looking at forecasting. And also, it might not be possible. Suppose I want to study the economy of India. Now looking at Indian economy, there are lakhs of companies which have been registered. I'm not talking about the ones that you see on CNBC, that trade on the exchange. I'm talking about companies, private companies, public companies, small firms, proprietorship firms. Suppose if I want to study the whole economy as a whole, as to how India is doing, you will not have that kind of resource to study every single company in India. You will not have that kind of data. And by the time you're able to analyze that data, you'll have 2 years gone and the data will become stale now. So it becomes a problem. What we do is, we suppose look at Nifty, which has 51 companies. We look at that sample 51 companies and we try to study that 51 companies, because that is representing, those are the large companies of the major sectors, major industries in the economy. Based on the movement of those 51 companies, we judge as to how India is performing, as to how the whole economy is performing. You're studying a part of the data and you're trying to comment on the whole population of the data. Out of the whole population, you take out a sample, you study the sample, you analyze the sample, and on the basis of that, you try to give an answer about the population. So you study the sample and you try to make forecasts, or you try to make judgments, inferences, you draw conclusions about the population of the whole set of data. So there's a lot of stuff that we are going to do over here. I'll come back to it. Now, when you're studying the sample, what are the different attributes? What are the different things you want to study? So let's start off with the mean median mode part first. We'll do it from the very basic. So even if you're in 11 and 12, it doesn't matter, right? So mean median mode. When you're talking about mean, you're talking about the average. Now suppose I collect, let's say 100 days of data. One day I earn 10%, another day I earn 12%, another day minus 8%, then 7%, someday 17%. So I have a lot of data points over here. I have collected 100 days of data or 1000 days of data. Looking at the 100 or 1000 days of data, you will not understand anything. You will not be able to draw any conclusion on the basis of that. The random points, I've got 1000 percentages, 1000 values. What do I do with that? I want to understand that what is my average data. So basically I'll know that around this my data point lies. On an average, I'm earning this much return, and most of my data is going to be arranged around this particular level. So what is the average level? That is why mean, median, mode and mode is known as measures of central tendency. If you guys remember, you have done something of this sort in class 11. Mean, median, mode is measures of central tendency. So I'm trying to understand around what point, around what level is my data arranged. Around what level is my data arranged? Around what point is my data going to be arranged? So that is what I'm trying to understand with mean. Mean is simply your average. Now mean can be of 3 types: arithmetic mean, geometric mean, and harmonic mean. I'll come to that a little later. But when we are talking about mean in general, we are referring to arithmetic mean. When we are talking about mean in general, we are referring to arithmetic mean. We'll come to AM, GM, and HM a little later. So when you're looking at mean, you're just taking the average of all the 1000 values. So it is very simple. You sum up all the values and you divide it by n and you get the average. So you're summing up all the values together and you divide by the number of observations and you get the average. That is very, very simple. So the average of this whole data set is this much. Now what do you understand by median and why do you need a median? Now what median is going to do is, median will divide this 1000 data points into 2 parts. 50% of the data points lie below this level and 50% of these data points lie above this level. A very simple example that again I use generally is with respect to the B school salaries. Now when you're looking at the Indian B schools, they will give you the average salary, the mean salary that people are drawing. When you look at the B schools abroad, they are giving you the median salary. Now what is the difference and why is it so important to understand the difference between mean and median, and why do you need both the terms? When you're looking at mean, suppose there are 4 candidates. One got a salary of 10 lakh, another got a salary of 12 lakh, another got a salary of 14 lakh, or let's say there are hundreds of candidates like this. The average would be somewhere around 12 lakh. Now suppose, or let me take 10 candidates, it will make my calculations easy. You have 10 candidates in your college, in your B school. The candidates are getting a salary of 10, 12, 8, 11, 14, etc. More or less everybody is within the 10 and 12 range, and your average salary is 12 lakh for per candidate. Now suppose what happened was, except for one candidate, all the 9 candidates got the same value, the same salary, but one candidate got placed outside abroad and he got a 1 crore package, which these guys are going to publicize in the newspaper very well, their PR team, right? So suppose, I'm not saying that all colleges do that. All colleges don't do, the ethical colleges don't do this kind of stuff. So suppose there are 9 people who got that kind of range of salary, and there is one guy who ended up with a 1 crore package because he got a job abroad. So when you're comparing the cost of living and all that, it's not that great also. It's good, it's very good salary. Let's say 100 lakh salary. Now, Suppose your average will become 9 into 12 plus 100 divided by 10, something of that sort. There are 9 salaries which around 12 value. Let's just take a rough figure. There are 9 candidates who got a 12 lakh salary. And there is one candidate who got a 100 lakh salary, that is a 1 crore salary. So this becomes 108, 208, 20.8 becomes your average. Don't you think this is distorted? Don't you think that on an average, I'm just talking about in a rough manner, on an average, don't you think the candidate's salary should be around 12 lakhs? By having this extreme event included, extreme outlier, because it's lying outside the normal range of data. Your normal range is between 8 and 14. It's giving you an average salary of 12 lakh. But your average, when you calculate the mean, it is going to turn out to be 20.8 lakh. Don't you think this extreme outlier, we call it an outlier because it is lying outside the normal range of data, outside the normal range of most of the data. So don't you think because of this particular one data, your average has gone up, shot up to 20.8? But actually your data should be somewhere around 10 or 12, your average should be near close to 12. It's one exception which is distorting your whole data. The average, the mean is going to get distorted by the data in this manner, by an extreme value. And even if it's like 100 lakh over here, what if there are one person who gets a 1 lakh salary? Or one person gets a 0 salary because he does not go for placement? Generally the institute leaves those guys out. But suppose someone got a salary of 2 lakh. Let's say, I know it's very, very hypothetical, but let's say your average will be exceptionally down. Your average will come down exceptionally low. So your average is going to be distorted by an extremely high or an extremely low value. In the B school example, an extremely high value is going to make the average 20.8. And looking at 20.8, everybody will be going to that college. What should be mentioned and what is mentioned in most of the US colleges is the median salary. What does median salary mean? Median salary tells you that 50% of the data lies above this point and 50% of the data lies below this point. So what we will do is we will arrange all these salaries in ascending order. We will arrange all these salaries, all these packages in ascending order. Now, if there are 10 packages, I want the 5 packages on this side, 5 packages on this side. So the average of the 5th and 6th value should be the divider, which is dividing that beyond this level, 50% data lies above this level and 50% data lies below this level. So you arrange the data in either ascending or descending order, doesn't matter, and you take the position that is absolutely in between. Because beyond that level, beyond that value, 50% data lies this side and 50% data lies below. What does this indicate? This is known as median. This tells you that 50% of the class of the MBA students are getting a salary above this point and 50% of the students are getting a salary below this point. So if your performance is above average in the college, you will get a salary above this level, and if your performance is below average out of those 50% candidates, then your salary will be below this level. Whether you have 100 or 1,000 or 10,000, it won't distort the median. Median is not going to be affected by the outliers. So understand why we are studying mean separately and median separately. What is the utility of one measure of central tendency with respect to the other? Because even if you've studied these things in class 11 and 12, I doubt if you would have understood the difference between the two in this level. So statistics is all about understanding again, and even if you've not had statistics in 11 and 12, don't worry about it. Are you understanding the difference between mean and median? And it's a very important difference. Why do you want to study both the measures? Mean is giving you an average. The average is going to get distorted by very high values or very low values, because every single value will have 1/nth of representation in the whole mean, because every value, all the values summation divided by n is what you take as an average. So every single value will have a 1/nth portion in the average. 1/nth representation of every single value is there. But median is not going to get distorted by extremely high or extremely low values, because it is giving you the value in between, that 50% data lies above this level and 50% of the data is going to lie below this level. So you divide the data, you arrange the data in ascending or descending order and take the centermost points value. Average is giving you the central value, but median is giving you the center positions value. So you divide the data into 50% this side, 50% this side, and whatever is the value in between is going to be your median. It's going to be your median. Comfortable? So that's the difference between mean and median. So mean does not. We will do these things. When we do skewness and all these things, I'll make you mark, I'll make you write all these things later. Just have a very good understanding right now. So mean is going to get distorted by extreme values. Median will not get distorted by extreme values. Mean is the average. Median is the centermost position's value. The position is center. The value in that position is what median tells you. And mean is telling you the average, the centermost value. And this is centermost position's value. Mode is kind of a little useless, we don't use so much. That is the highest frequency. So when you're looking at the average salaries or anything that anybody is trying to project, please be very careful as to whether they are giving a mean salary or a median salary. And then see whether that college is having a lot of international placements, because international placements, if the cost of living is high in those countries, automatically you end up giving a better salary to these guys. There is an XYZ school, I'll not take any names. So these guys had a lot of placements in Africa, and there you have to give salaries of 40 lakh or something. The average salary of the whole college would be anywhere between 4 and 5 or 6. But their average salary, what they were showing, was 12 or something, because they had a lot of placements in Africa and abroad. And that distorted the whole calculation. So that is misguiding, that is misleading. So we need to be very careful about it, right? Alright. So now you established, now you understood. Okay, mode, sorry. So the data with the highest frequency is the mode. Now when you're looking at normal data sets, we will do distributions later, but I just need to introduce the topic. Most of the data, don't you think that most of the data should be occurring around its average? Now say suppose we'll take, let's say, the average time you take to go from home to your office. The average time of commute between your house and your office. Suppose on an average every day you take 25 minutes to reach your office from your house. Don't you think most of the days you'll be reaching the office in 25 minutes? A good number of days you'll be reaching in 26 or 24 minutes. There'll be very less number of days where you take 35 minutes. Even lesser number of days where you take 40 minutes or 45 minutes. Very less number of days you will take 15 minutes. It'll be very, very exceptionally low number of days where you take 10 minutes or 5 minutes. Exceptionally low. So basically most of your data should be happening around the average. As you move away from your average time time of commute between your house and your office, don't you think most of the days is going to take you 25 minutes? A good number of days you'll be taking 26 minutes or 24 minutes, 27 minutes or 23 minutes. Less number of days you would have taken a very, very high amount of time, and very less number of days you would have taken an exceptionally low amount of time. Normally, most of the things in the market, in all your surroundings, should be more concentrated around the average. Most of the stuff should be happening around the average. Let's say, for example, a company on an average earns, let's say, 10% return. Don't you think in most of the months your return should be somewhere close to 10? It will be very less number of days wherein you might have earned an 18, 20, 25% return, and very less number of months wherein you would have earned minus 10, minus 5, minus 8% kind of return. Your factory's production is 1 lakh units. So sorry. Your factory's production is, let's say, 1 lakh units, right? It will be very less number of days where your production has gone to 1,40,000 units per month. Most of the months you'll be producing 1 lakh, 1,05,000, 95,000, something around that. So most of the production quantity is going to be very much concentrated around the average quantity that you produce. So mode tells you, so that is why most of the frequency should be around the central data that happens more often. It should be somewhere in the center. It is possible when you're looking at the practical sense of data, it is possible to have bimodal data. That is, two data points have the same frequency and the highest frequency. But are you understanding what I'm trying to comment on from a very practical point of view? That mode should be somewhere centrally located in your data. Mode should be somewhere very, very centrally located in your data. Most of the data should be happening around the area, around the position where most frequent data occurs. Are you understanding what I'm trying to comment? That most of your observations should be around the average. These are the values, these are the probabilities, suppose. So most of the observations should be around the average. As you go to an extremely high or an extremely low value, the number of outcomes or the probability or the frequency of those outcomes should reduce as you're moving away. Practically makes sense. Very extremely high and very extremely low values should be less probable. There should be more data or more chance of having your data points around the average. Excuse me. Everyone following this part? That is mode, the data with the highest frequency, and that is why that is also a part of your measure of central tendency, mean, median and mode. Mode is going to be relatively less useful, mean and median is going to be extremely useful. Is everyone understanding? So your data is going to be somewhere around mean, median or mode. Your data is going to be somewhere around mean, median or mode. So that gives you kind of a central value. So instead of looking at 1,000 returns, using which or analyzing which I'll understand nothing, I need a ballpark figure. I need kind of a central value. Okay, most of the returns are around this level. Okay, the average return is this. Okay, 50% returns are above this level, 50% returns are below this level. Okay, this is the return that occurs most of the time. Are you understanding the difference between the three measures? So I've established a level, I've established a benchmark that most of my data is around this level, whether it be mean, median or mode. Generally, we are going to stick to our mean for most of your calculation. But now I want to analyze as to how the data is arranged around the mean. Is the data, like say suppose my average return is 12%, is most of the data between 8, 9, 9.5, 10, 10.5, 11, 12 or something? Is it very, very concentrated around that 8, 12 range? Or is it very, very spaced out? Like something is 7, sometimes it's minus 10, sometimes it's plus 10, sometimes it's plus 20%. So I want to understand how the data has been arranged like that. Now tell me, understand that if I tell you there is a stock A, there is a share A, company A, and there is a company B. Company A's average return is 12%. Sometimes it is giving you 8, 9, 10, 10.5, 12, 12.5, 9, 10. It's more or less within that range. There is another company, company B. Now company B is going to give you a minus 5%, 25%, 30%, minus 12%, minus 7%, 8%, 12%, 50%, minus 30%, but the average is still 12. Which stock do you think is riskier, stock A or stock B? Stock B. Because there is no certainty whether it's going to give you a 20 or a minus 20 or a 30. You don't understand that. The data is moving around this way, around the average. But in this case, the data around the average is moving in a very, very narrow range. Narrow range. So we need to understand how has the data been arranged, distributed, organized, dispersed around the average. This is the central point. But what about the rest of the data? How is it arranged? Is it arranged in this manner around it, or is it arranged in a very, very narrow range over here? So this is where we start measuring the risk of the data, because you said that this stock is going to be much, much more riskier as compared to this particular stock, because this one is very, very random. This one is in a narrow range. So we need to have something called the measures of dispersion. So the first one was establishing a central point, and the second row we are going to look at how to understand the range of data, how to understand the distribution of data around its average. How is the data scattered around the average? How are the values of the data? For that we are going to study this part. It's very simple. Now when you are looking at the range of the data, the range is very simply the maximum, the highest value, the maximum value minus the minimum value. So basically when you're looking at this stock, the range was given as the lowest possible outcome and the highest possible outcome. So this becomes a range of the data, and that tells me that the data is arranged or the data is distributed within this particular narrow range. When you're looking at this stock, the data was arranged in this broad range, wide range. So the range of the data, the distribution of the data, the breadth of the data is this much. The data is arranged between these values. That becomes your range. It's a very preliminary measure, now very important. Then you get into the absolute mean, absolute deviation. It is exactly as the name suggests. Now I want to understand how the data has been arranged around its mean. Suppose my data set is 10, minus 10, 0 and 10. My average is, let's say, 0. You can add a minus 20 and a plus 20. I'm taking these figures because it makes my calculation easy. Now if you see, Around the average, this data is 20 units below, 10 units below. Sorry, I should have reversed it. I can. This data is 20 units above average, 10 units above average, 10 units below average, 20 units below average. If I sum up the deviations, it will give me 0 because the plus 20, plus 10, minus 20 is all going to cancel off each other. When I try to find out what is the deviation of the data around its average, some deviations will be positive, some deviations will be negative, and they will cancel out each other. I am not trying to find out what is the amount, what is the direction. I'm not talking about the direction of the deviation. I want to find out what is the average distance. If this is my average, is the data arranged around this manner or it is arranged at this distance? I'm not talking about whether it's above or below. I want to understand what is the distance of the data from the average. How far is the data arranged? I'm trying to understand that. So in that case, what I do is I take the values x minus x bar, I take the summation of the averages. So this minus this, this minus this, this minus this, this minus this, this minus this. So all the observations minus average will give me the distances from the average, but I don't want to bother about whether the distance is positive or the negative. I want to find out the average distance around the average. I want to find out what is the, on an average, what is the distance between the data sets, between the observations from its own mean. So I take the absolute value of the same. So there is no sign now. This is the deviation and this is the absolute deviation. And I want to find out what is the average absolute deviation. This becomes the mean absolute deviation, deviation absolute mean. This will tell you that from the average, from your mean of the data, on an average, what is the distance between all the data sets, all the observations from the mean. What is the average distance of all these observations from the mean is what you will get from mean absolute deviation. Is everyone understanding? So your mean absolute deviation is very simply summation of x minus x bar's absolute value divided by n. That is the mean absolute deviation. Is that correct? Is everyone fine with this? Now the problem is that with this kind of a data, it becomes very, very difficult to do any calculations because absolute value, you will not be able to do many calculations. You cannot put it in formulas and work it out. What is the other very good way of getting rid of the signs? Because we don't want to bother about whether the deviation is positive or negative. We don't want the deviations, the positive deviations to cancel out the negative deviation. Say for example, your data is minus 200, minus 100, 0, 100 and 200. Again, I did that. The average is still 0, but don't you see this data is dispersed way more. There is way more distance. That is what we are trying to measure over here. The average might be the same, but how is the data distributed around the average is what we need to study. And we don't want the sign to influence it. Because if you take the average, the deviations, they will sum up to 0. Deviation is 200, 100, minus 100, 200. The deviations will be 0 from the average 0. I want to get rid of the sign. I want to get the average of the deviations, irrespective of whether the deviations are above or below the average. So in that case, the other very nice option of getting rid of the sign is squaring it up. And that gives you your variance. That gives you your variance, the average deviation of the values around x bar without the sign. So we square it up. So the variance part is also very, very interesting and very useful. And the term tells you variance, how is the data varying from its mean? That is why variance. But there is one problem that still remains with your variance portion. Now say for example, a 4% whole square, a 4% square is not equal to 16%. Please don't make these mistakes. 4% square is 0.04 square, which is equal to 0.0016, which is equal to 0.16%. 4% whole square is actually 16% square. When you do any kind of multiplication, division, squaring up or etc., it also does the calculation on the unit. When you do a distance divided by time, you get the speed, and the speed's unit is kilometer per hour. If you multiply the distance by time, that is if you multiply the speed into time, you will get the distance because r and r get cancelled. So your units also are working with the calculations. Your plus, minus, your multiplication, division and all work on the units as well. So in that situation, what do? We need to standardize this measure because the whole square data is giving me no analysis. I cannot interpret 16% square. What is 16% square? What is percentage square? It does not give me any kind of an answer. I cannot understand. I cannot put it in a statement. 4% whole square, 16% square is nothing. You cannot comment about it. We need to standardize the variance. How do you standardize this variance? By taking a square root of the same. So you standardize the variance, and that is why it is termed as standard deviation. Now, if the standard deviation of the data turns out to be, let's say, 4% or something, you can say the average deviation from the average, from the mean, on an average, the data is 4% away. So, some observations are 1% upper, some observations are 5% above, some observations are 10% above, 5% low, 10% low. But if your standard deviation is 4%, you can say most of the data on an average. Some data could be 1% above, 0.5% above, 12% above, 10% above, 10% below. But on an average, the data is 4% above or below the mean. Above or below the mean, because standard deviation is without a sign. So standard deviation standardizes variance. So I can use SD to make the statement that on an average, the data is 4% above or below the mean. But you cannot make the same statement with respect to your variance. But you cannot make the statement with respect to your variance. Is everyone comfortable with this? Everybody is sure? 100% with what is range, mean, absolute deviation, variance and SD. Why are you naming it in this manner? What do they mean? What do they imply? Let's next we move on to skewness and kurtosis. When you're looking at skewness and kurtosis, the standard deviation will just tell you how the data is moved around, distributed around its average. What if we have an exceptionally negative value? What if most of my data is around this range, but I have a huge exceptionally negative value? What if my data is distributed in this manner, most of my data is around this range, but what if I have an exceptionally high value over here? Skewness is going to tell you whether you have an exceptionally high or an exceptionally low value anywhere. That is what skewness measures. That is what skewness tells you. Whether you have an exceptionally high value. See, range is going to tell, variance or standard deviation is going to tell you how the data is distributed around the mean. It's not going to tell you whether you have an exceptionally high or an exceptionally low value. Skewness is going to give you this information. So now, when you look at the formula of skewness and kurtosis, I'll come to kurtosis, I'll do the formula right away. X minus x bar whole cube summation divided by n is known as your third moment. So when you're looking at variance, that was your second moment, x minus x bar whole square divided by n. There is something called a moment around the central value. So x minus x bar whole cube divided by n will give you your third moment. We standardize it by multiplying with SD cube and you get your skewness formula. So basically x minus x bar whole square by n was variance, x minus x bar whole cube by n is third moment, x minus x bar whole to the power 4 by n will be your fourth moment, and you will standardize it. Basically, try to understand percentage cube divided by SD cube. SD will also have the same unit. Kilometer cube by kilometer cube is going to cancel off. So this becomes a unit free measure. Understand 25 kilometer divided minus 10 kilometers is 15 kilometers. When you do A minus B, your unit still remains. 25 kilometers divided by 10 kilometers is not 2.5 kilometers. It is 2.5 times. 25 kilometers is 2.5 times of 10 kilometers. So 25 kilometers divided by 10 kilometers is 2.5 times. The units get cancelled. 25 kilometers minus 10 kilometers is 15 kilometers. Are you understanding? So these things you should have known in class 8, 9 or 10 or something. So when you're doing 10% minus 5% is 5%. 5 percentage cube, and SD also has the same same unit, kilometer, because we had standardized it. We had standardized it by square rooting the variance part. So the units will get cancelled. Over here the units get cancelled. So the third moment is being standardized, the fourth moment is being standardized, and you get the skewness and kurtosis value. I will discuss this more in detail. Now one thing, if you have noticed, skewness, you have the value, you have the cubed value over here. Minus into minus into minus is minus, plus into plus into plus is plus. So the sign is retained. Therefore, if you have an exceptionally negative value, you will have a negative value for skewness. If you have an exceptionally positive value, your skewness should be positive. And if your data is distributed exactly in the same manner around the average, in that case your skewness will be equals to 0. This shape is what the skewness is measuring, and that is why, do you understand, since there is a cube, the sign is being retained in skewness. Since there is a cube over here, the sign is being retained in skewness. This is, since it is skewed on the left side, we call it left skewed as well, and this becomes right skewed. This is symmetrical. Following? The highest frequency data becomes your mode, which is very, very obvious. That's the highest frequency, that is your mode. Now, if you have an exceptionally low value, don't you think your mean is going to be pulled towards this side? If you have such a huge negative value, your mean will be lower because of this value. But median does not get much affected. That was the advantage of using a median. It is not distorted by an exceptionally negative value, because median is the central positions value. It does not use this value inside its calculation. It is talking about arrange all the data in ascending order, descending order, and give me this one. But mean will get this value represented inside. It is a summation of all the values divided by n. In this situation, your mean is going to be over here. Your median again does not get very, very distorted. Your median always turns up between mean and mode. And in this case, mode is equal to mean is equal to median, because exactly 50% of the data is arranged around this and in a very proper manner. We'll do distributions in detail, but this is your skewness. Your mean is going to be pulled towards the extreme value, because mean is incorporating that all the values. It gets affected by the extreme outliers, extreme values. But median is not going to get affected. It is dividing your data into 50% on this side and 50% on this side. Is everyone comfortable? That is skewness for you, and the calculation is done this way. And since it is either skewness is 0, positive or negative, it is a unit free measure. It doesn't depend on whether your data is in lakhs, crores, millions, billions. Doesn't matter, because ultimately all the units will get cancelled and we are going to be looking at a 0, positive or a negative. We are standardizing your movement, and therefore we are getting skewness over here. Skewness is giving the direction. It has a power 3. So the minus sign is retained, the plus sign is retained. Standard deviation does not have a sign. It's positive always. Is everyone comfortable till here? Till now, you have been studying the attributes of only one data set. We have not started looking at the relationship between SBI and interest rate. What is the average price of SBI or average return of SBI? How are the returns distributed around the average? Do we have an extremely high return or an extremely low return in case of an SBI return, in case of the stock SBI? And the last one, kurtosis. See, on an average, in general, practically, most of the data should be arranged around its average. As you move away from average, your observations should go down. But what if my distribution is in this manner? Let me give you an example. Average return 14%. Most of the returns are around 18, 16, 13, 12, 10. These are most of my returns. There are 100 returns like this, 150, 200 returns like this. So most of the returns are around in these values, right? I'll give you another option. Average is 14%. There are hardly any returns around 14.5, 15, 16 or 17 and 12, 13 or 14. Most of the returns are around 6%, 7% or 21%, 22%. Which stock do you think is more risky? Where the stock, when the stock returns are either 14, 15, 16, 18, 10 or something like this, or where either the stock return will be 14 or it'll be 6, 7, 8 or something, or it'll be 21, 22, 23. This is more risky. This part is not going to get captured by either skewness or standard deviation. This is not going to get captured by standard deviation or skewness because you don't have values around this over here. Standard deviation will have values at 16, 17, 18 also. This does not have any of those values. Standard deviation might not be able to capture this part. This is going to be taken care of by kurtosis. Now try to understand the graph. Normally, your data will be around the average. As you move away from the average, your number of observations will gradually go down. So as you move away from the average, you will have lesser data points away from the average, which is very normal because most of the data should be concentrated around the average. In kurtosis, what we are saying is either you have a lot of data exactly at the average. The moment you go 1% or 2% or beyond, you hardly have any observations. See? And there is a lot of observations compared to the normal. You have a lot of observations in the tails of the data. It is not an extreme value. It is not an extremely low value. What we are saying is more data is concentrated around the tails of the data. More data is concentrated in the tails of the data than around the data. There is very less observation. There is hardly any observation around the average. There is more observations away from the average. That is what kurtosis is measuring. And kurtosis is giving you whether the tails are fat or not. It is not talking about whether it is positive or negative side, and therefore can you see there is a positive sign always over here. It is not talking about whether there is more concentration on the negative side or the positive side. That's not what we are looking at. What we are looking at is whether the data is more in the tails and less around the average. In general circumstances, if your average return is 14%, you should have gradually your observations away from 14 should go down. So when you have a 14% return, you should have a lot of 15, 16, 13, 12, 12 and a half. You should have a lot of returns in that range because the average is 14. So you should have a lot of concentration, a lot of observations in that area. In kurtosis, what we're trying to see is suppose if a stock has got either you have a lot of 14, 14 and a half, 13 and a half range, but then you've hardly got returns between 10 and 14 and 14 and 18 or so. Then suddenly the returns are around 20, 22, 23 or suddenly around 5, 6 and 7%. So that is very weird and that is risky because you're being more extreme. You're being either this side or this side. You will be more certain, you'll be more sure, you'll be much more safer when you have most of the data arranged around the average, around the central area. You should have more observations around the average, and as you move away from the average, you should be having lesser number of observations. Is everyone finding it? Is everybody understanding this part? Getting an idea about what kurtosis is? So till here, when you're looking at mean, median, mode, standard deviation, range, skewness, kurtosis, you're studying one single data set, SBI returns. You've not yet started looking at the relationships. What if I want to analyze as to how is the movement of SBI happening with respect to interest rate? For that, to understand the movement, are the two data points moving in the same direction? So if SBI goes up, interest goes up, SBI goes down, interest goes down. Or if SBI goes up, interest goes down, or if interest goes down, SBI goes up, and if interest goes up, SBI goes down. Do they move in opposite directions or do they move in the same direction? Can I form an equation? SBI price is equal to something plus something into interest rate. Can I form an equation between the two? So correlation covariance is going to tell me whether they move in the same direction or they move in the opposite direction. And regression is the method using which we frame an equation between the two values which are related. So correlation covariance is going to tell me about the movement. How is the data related to each other? How do they move with respect to each other? Regression is going to talk about how can we form the process in which we form an equation between the two data sets. Covariance becomes very important when you're looking at it from a risk point of view or a portfolio point of view. Say for example, I own two stocks, stock A and stock B. If stock A goes up, stock B goes up. If stock A goes down, stock B goes down. So if in that situation, either my portfolio, my two stocks together go this much or this much. But what if I have two stocks, stock C and stock D? If stock C goes up, D goes down. If stock C goes down, D goes up. So on an average, in totality, my portfolio return will average between this range, because if one is increasing, the other one is balancing out, and the other one is balancing out in other situation. So the total return will be in a narrower range. Which one do you think is more risky? The portfolio moving this way or the portfolio moving this way? The first situation is more risky. So whether the stocks are moving in the same direction or in the opposite direction is going to be important to calculate how the portfolio, how the stocks together is going to perform. That is going to be taken care of by covariance and correlation. And to form an equation between two related variables, how do we come up with an equation like a y is equal to mx plus c or a y equals b0 plus b1x? That is the regression method. So we will use regression method to form the equation. That is what is there in your basic statistics. Is everyone absolutely comfortable till here? Understood everything?